Uh, all right. So this is the program that we have seen in the last class where we read names from a file and we read names from a file uh, and what do we do? So we sort them and write them into a sorted file. This is what is present in namesort4.c. So it has four functions. So one is read names function, other is print names function, the third one is swap function, the fourth is sort names function. And if we go back to namesort 3 or namesort 2, uh, so where our uh, so where we are storing names using an array of character pointers. That's what we were doing in namesort 2. And in namesort 1, we are storing the names as an array. Okay, it's an array of names. This is what we have, right? So a couple of things we will see. Let's take a look at this one. So now what we would like to do is we would like to take this, when we are working with real big projects, there could be some parts which your teammate could be working on and you could be working on some part, or you could be working all alone but you would like to nicely organize your code into different files. Like for example, all helper functions for strings in one file and all helper functions for something else in some other file, things like that. So let's say we want to take this name sort4.c and we want to have the helper functions, read names and print names, swap, sort names, all these things in a different file. So let's see how this is what is called as multi-file multi-file programming. So there are some important ideas that we should consider here when we go for multi-file programming. So here, let's say what we have is sorting. Yeah, maybe I should use a different folder, multi-file. Yeah, and then here I can have something like main.c. I'll have two files. One is main.c and one more file. Let's say control is helper.c. So I'm just taking this whole code, control A, control C from name sort 4, copy pasting it here. And so here what I would like to do is I would like to have all these helper functions. I would like to have all these helper functions in a different file, helper.c. Right, and then so now if you see, main has only the main function and it doesn't have any helper functions. The helper functions, they are in different file. And but you can see that that there are some so init underscore list, there are few things which are not it says they are not defined here. So possibly what we can do is that main doesn't need, so I don't know what main requires, but let's say we have all these things in here. We have, I think this should be all right. Are there any problems here? So in main, primarily, we don't need any other include file except stdio.h, and helper.c, which uses bool and other things. So because of that, it requires std bool. Okay, I think it somewhere it uses bool, like for example, on line 59. But you can see that no max name underscore length, it is a uh, yeah, init underscore list. All these things, they are used in helper.c, but they are not defined. So there is a problem. So, and it also so turns out that these variables are not used in the main.c file. But sometimes we may need to use these macros in main.c also. So due to that, we can kind of keep it in something called as header.h. So now our whole code is present in three files. One is header.h, in which we define these three macros, and main.c contains stdio, no, this main function, and helper.c. Helper.c, it is using printf, etc. So it should also need hash include stdio.h. And then, so we have to include this header.h. So now once this header.h file is included, so like all the macros are defined there. So you can see that all these init underscore list.c and all these things are gone. So they are not required. Great. So now this is how we have split the whole program into multiple files, and let's see how we can compile them. Okay, gcc multi-file, gcc main.c, header.c, oh no, helper.c. So what is the problem that we are getting? Undefined reference to main. Maybe we should compile this in this order. We need to define header in main.c. No. Saved. No, we didn't have header.h is not required in, no, a header.h is not required in main. It is required only in helper.c. Because in main, we are not using any of these macros. What file name I didn't include? Definitions of helper are not declared in, main, okay. But why is, okay. So now I can see, okay, great. So we are good. I just want to check one thing. Now, can you see the, yeah. So can you take a look at my screen and see what are all the errors that we are getting? What are all the warnings that we are getting? In main, we are using, are we using exit? Let's look at warning 16.9, implicit declaration of function exit. Yeah. So on line 16, there is a problem. Please pay attention. So on line 16, there is a problem. Probably it's not an error. So we are calling the exit function. Exit is present in stdlib.h. So let's put exit here, hash include stdlib.h. But one thing I want you to pay attention, if the function prototype is not available, when you include stdlib.h, the signature for function exit will be included. If it is not available, the compiler will implicitly assume that the exits has some type. Okay, GCC helper. So now you can see maybe no, there's lots of warnings here on 16.9. Is it? Yeah, now here. So on line 16, that exit warning is gone after including stdlib.h. So what I'm trying to tell here is, please pay attention. When we use exit, the prototype for what is a function signature or function prototype, the function prototype contains what are the argument types for the function and what is the return type for the function. So if you don't have it, then we will get a warning, like you can see, where is the warning? Yeah, this is a warning that implicit declaration of function exit. That is, I am not finding a declaration for the function exit. I am implicitly assuming a declaration, that is exit. The implicit declaration for exit is 0. That is, whatever exit we are right now passing an integer as a parameter. Based on that, the possibly the function, the compiler is assuming some declaration for exit. But in any case, but after we include stdlib.h, that warning will be gone. In case if you are find difficulty finding this, this is our current compiler output. Are you with me here? How we got rid of? No. See, stdlib.h, the compiler compiles. Good question. So I will tell you now what happens. So what happens is the compiler main.c helper.c. Good question. The question of Aditya is, why is stdlib.h required in main.c? Because it is present in helper.c. What happens is each file will be compiled separately. Main.c will be converted into main.o and helper.c will be converted into helper.o. So the compilation of main.c and helper.c, they will happen independently and both will be linked using a linker. So using a linker, the linker program is LD. So using a linker, both will be compiled and an a.out will be generated. Are you with me here on this point? How many of you are with me that compilation of main.c and helper.c happens separately? And the linker will link them. So a few more things I would like you to observe here. So one is string copy. Again, we are using string copy in main.c, but we are not including string.h. So again, it is complaining, that is, there is a warning. And similarly, yeah, so string cat we are using in main, but we didn't include string.h. Are you with me on the warnings, that the two warnings are highlighted? So how can we get rid of the two warnings? The way I can get rid of the two warnings is by including string.h. I have to confess one thing. So I was traveling last 3-4 days. So I didn't prepare for today's class. I'm just coming straight and doing things. So it has its own advantages because I keep making errors and new things will come up. So yeah, clear all my drawings. So now let's compile this. So now if I compile this, let's see uh, what problems you have. Read names function, sort names function, print names function. We are main is calling them, but yeah. So main is calling them, and but those are not available. If we didn't have a helper.c, it would have been you don't include helper.c, Vivek, in preprocessor. That's not how it works. It is possible to include .c files also, but that's not how we do things. How many of you understood the warnings on these 3 lines? So now I want to check one thing, because as I said, no, I didn't quite prepare for this class. I want to see if I change the order in which I compile, what will happen? Let's see. I still get the same warnings. It's not going to change. I'm thinking maybe if I change the order, I'm highlighting this. Okay, clear. Okay, clear all my drawings. So the warnings when I compiled GCC helper.c main.c versus GCC main.c helper.c. See, I explained it's an exam question that you don't include libraries. You only include function prototypes, function signatures. We include only function signatures. I want to see if the .a.out got created. So .a.out got created. Yeah, so it worked. Okay. Are you with me here? How do we get rid of these 3 warnings? See, right now, when you should, I think, could you hold on the discussion in the chat window for some time? What I want you to point out here is, in main, we are using read names, print names, and sort names functions. Are you with me on this one? Number one, let's take step by step those of you who got lost. In main, we are using 3 functions: read names, sort names, print names. These are the 3 functions that we are using. Read names on line number 33, sort names on line number 36, and on line 44, print names. These are the 3 functions that we are using, and these functions, they are not defined in the main.c file, but they are defined in the helper.c file. In the helper.c file, read names, print names, and sort names are defined. All right, number one. Number two, so when we give these 2 things for compilation, when we want to compile multi-file programs, so you just list out all the names on the, like this, GCC main.c, helper.c, you compile them on the same line. So now what happens is the compiler is able to find read names, sort names, print names in the helper.c file. So it is fine with it. The order doesn't matter here. That's what we tried out here. Maybe it matters in some cases, but right now in this particular case, it doesn't matter. All right, number two. Uh, but the problem is, as I said earlier, the compiler compiles them. The compiler compiles actually this is what happens. Let me show you. Uh, this is what underneath, this is what happens. So gcc main.c minus c, that is don't so it generates when you do gcc minus c main.c, main.o will be created, an object file will be created. Please pay attention here. And then gcc minus c helper.c, again helper.o will be created if you do ls star.o. So helper.o and main.o are created. And then, so we have to link these two things. So now if you see, by using minus c, we are able to compile helper.c file, even though it doesn't have the main. But if I just say gcc helper.c, it's not going to work because it will complain that it requires the main function. But if I see gcc minus c, then what it says is it generates an object file, what is called as an object file. So we have ls star.o, so we have these two. So now what we do is, so we have to use the linker. I don't know whether how to use the linker exactly, but let's try it out. ld minus helper.o if it works. Yeah. So this ld thing, it kind of doesn't work because we have to link main.o helper.o with some other libraries. And I don't know what libraries to use uh, as we should pass parameters as because printf, the code for printf, the code for string copy, string cat, they are all present in some other library file. So we should be able to, we have to pass those libraries also as parameters to LD so that it can successfully link main.o, helper.o, and all other library files to generate the a.out. Guys, you should pay attention to what I'm saying. You are thinking in your own way. You should for some period, you should listen to me. Okay. Um, yes, I'm just trying to see whether, yeah. So in order to know what libraries to include, I'm just using a what is called as a verbose compilation option to see what libraries. Okay, let me, yeah, let's do one thing. So there are few questions here, and all right, guys. So I think I want you to pay attention here, please. Okay. So number one is, even if you take the simplest program, uh, like pun.c program, which we have written at the beginning of this course. Okay, possibly the first program that we have written, pun.c internally uses the printf function. Yes or no? I think you should all, so hold the discussion on the chat window and please pay attention. Pun.c uses printf function, right? So pun.c uses printf function. So in order to use that thing, in order to use the printf function, so pun.c says include stdio.h. This is your exam question also. I explained you at that time. It includes this statement, include stdio.h. And in the include stdio.h, it contains the prototype, whatever that prototype for printf. So printf, what are the parameter types for printf? What is the return type for printf? So only the prototype, this is what is called as a function prototype or a function signature. So this is called as a function prototype. Prototype means like what does it take and what does it return. And this is also called as function signature. The code for that will not be present there. The code for printf function will be present in some library. It is present, will be the actual code for it will be present in some library. The actual code, the code for it will be present in some library. Yeah, maybe I don't know in which source code. No, that is the source code. And again, here you have to distinguish between source code of the library and the executable or object. Source code versus uh, executable or object. Right. So this is the binary, this is the source. You don't need the source. You don't need the stdio.c or whatever the source file it is. You just need the compiled version. It is not even in assembly, it is in object code. It's in the encoding of the assembly. So what happens is your pun.c is translated to, is compiled to pun.o, and the linker links this with, let's say your entire library, it is present in stdio.o. I'm just taking an example, taking some random name, but that's not the name of it. The linker links these two things. So what happens in the linking process is a very interesting process. Wherever the calls for printf are there, so using these two files, the linker creates a kind of one complete image of the program a.out. And so it kind of the linker, it will point to wherever printf is used in your source code in pun.c, that printf will be replaced with a way to access the printf function code that is present in stdio.o. This is what happens, right? So are you with me here? At a high level, at some level, are you with me? What are the key things to remember? So the key things to remember is, what will stdio.h contain? It contains only the function prototype. It doesn't contain anything. This is number one. Number two is this, that that library, it doesn't contain the source code. It contains the binary. So the header file all doesn't tell where the binary is. That's where you have to give the path. Sometimes when you try to use some library, that library not found will be there. So you have to use some library path. It depends upon the operating system, how you specify the library path and things like that. Like for example, there is something called as ld underscore library underscore path, etc. Minus lm doesn't give you the path. Yeah, when we use GCC does all these things for us. Number three is the linking process. Number three is the linking process where your pun.o is linked with the library to generate the final executable. Are you with me on the points 1, 2, 3? So now the story is slightly, when we right now what we did here is in the current scenario. So we have main.c. So from main.c, main.o will be generated, and from helper.c, helper.o is generated. But if you just try to link these two, then only read names no, and print names, sort names will be resolved, but printf, string cat, string copy will not be resolved. Are you with me on these things? That when we link only these two, that's what we try to do using LD. only the what will be resolved main is using these names, print names, sort names, this capital N, and then it is using the third one is read names. Only these things are resolved because they are present in helper.o. But but then we are using other functions like string cat, printf, all those things. So in order for us to be able to use these things, we should link not only these two files, we should link also those libraries which contain these functions. Are you with me on this one? That when we did a link of these two, that's not enough. That's not enough. We have to link also those libraries which contain string cat, string copy, printf, scanf, all those things. fscanf, all those things. Are you fine with what I said now? So because of that, if I just do link of main.o and helper.o, you will see a bunch of errors. You can, like undefined reference to standard error, fwrite, string copy, malloc, strln. These are all functions which you are using, but we are not linking them with the library code. Because of that, we are getting all these errors. Are you happy? You understand, right? Does it make sense? But you don't get an error saying read names is not found, write names is not found, or sort names is not found because they are resolved. They are resolved because they are present in helper.o. That's true. We are manually linking. So if you know the library path for them, if someone can find the like Google and tell me the library path, we can try to see if we can directly link it and see if it helps us. Libn, I don't know. There's something you have to give the path minus libA. No. Let's see. / user libc. lib std libmpig. I'm just trying out luck. I don't have any idea where it will be present. Okay, let's not worry about it. So, yeah, I just thought if we can give it a. But what should we look for? I'm not sure where exactly. Yeah, this is waste. Okay, so this is a homework for you. Tell me, no, start libs, that's not going to help. Maybe find / star.so. Scary. Has many of has user lib. I don't know. Let's see what's the, if it works. Undefined reference to string dot. Okay. Anyway, guys, so you got it right. So you're all with me. Pramod has this thing, use minus LC option. Let's see minus LC. Cannot find entry to minus LC. Okay. Anyway, minus LA minus LC. Na? See, Vivek, you cannot link a .o file with .h file. Understand, you are still at the same thing. .h file is a source code. Okay, so it's okay. Let's not waste time. But I hope you understood the idea, right? I'm just trying to do something before you so that object file contains your machine code equivalent to your C code. Are you all with me here? What we are trying to do? Of course, we are not able to find that library path, but I hope you are all with me on this. What I'm trying to do, right? What we did is from main.c we converted into main.o, which contains the instructions which the processor can understand. Helper.c got converted to helper.o. When we link main.o with helper.o, these three functions, print names, sort names, read names, got resolved. But we are using more functions like printf, no, puts, gets, and string copy, string cat, etc. And so uh, so and yeah, so what happens is with all this, when we link with the other library, then we whole a.out is created. So there is this thing, if you use minus LC, it created a warning and not, so remove a.out. No, it didn't create, no? So LD minus LC main.o helper.o. Yeah, a.out got created. Yes. A.out names.text. Yeah, I think it's not. So minus minus entry main will remove the warning. Ha. So let's see. No such, why it is saying it's not ch mode plus x dot slash dot dot. No, names.txt is in the same folder. Anyway, let's not waste time. LD links the files. Okay, LD is what is called as a linker. LD links the files. Okay, it is like you did some job and your friend did some job. You have to link those two words in order to have the whole code. We have only 7 minutes, so we should proceed further. Is it all right if I move ahead? What is the difference between object code and assembly code? This I can quickly give an answer. You will study it in detail. Like for example, let's say if you have something like x is equal to y plus z in your C program, in assembly code, it will be something like this: add R1, R2, R3, assuming, no, like for example, Z is present in R3 register and Y is present in R2 and X is present in R1. R1, R2, R3 are some storage structures in your processor. But this add, no, this is an assembly which we can see, but your processor doesn't understand. But this needs to be converted into bits. Like for example, for add could be encoded using 4 bits like 0100, and register R1 could be encoded like 001, and R2 can be encoded like 010, and R3 can be encoded like 011. So this is the instruction encoding associated with this add instruction. So your object file contains this instruction encodings. associated with the source program. No. Object code is, are you with me? Are you with me in this example? X is equal to y plus z, and this is what your .o files contain, this binary code. Your .o files contain this binary code. I hope you're all with me on this one. A.out also contains the same, but it is linked. These are executable. So after all these things are resolved, no, then it will be ready for execution. That's what A.out file contains. A.out is a special kind of object file which is ready for execution. Can I proceed further? Is it all right with you guys? Okay, great. So here what we are doing is GCC. Since we don't know how to finish the linking process using LD command, so we just use GCC main.o and helper.o. So GCC does the job for us, and so .names.text, it got. Okay. I hope you're all with me so far on this thing. So I have few more important. So how do we? So now the question is. Uh, so the question for you is, how do we get rid of the, if I just use this, no? If I just use this, how do we get rid of these warnings? How can we get rid of these warnings? Yeah, so we have to include the function prototypes. So we have to include the prototypes for the functions. So Control C. So this is, we are including, so sort names. So before I include all these things, I want to tell you one thing. So let's say this is our code, okay? So are you with me here? So now, so I included them, but I commented them out because I wanted to prove, say one point. Now look at line 39. On line 39, we are passing FP, we are passing two parameters. If I kind of say this is the original thing, let me comment this out. But instead of this, if I have this, okay. So now, do you think it will compile or not? So sorry. Do you think the program will compile? On line 40, instead of the call on line 39, we have the call on line 40. Do you think the program will compile? Yeah. So now if you kind of helper.c, yeah, so it will still compile because it doesn't have any, it doesn't know what is the original prototype or function signature. It doesn't know. It doesn't know how it should be. The compiler doesn't know whether we are calling the read names in the right fashion or not. I hope you're all with me on this. So if you go see the read names function, this is the read names function. It takes the second pointer is file pointer, but we are not passing the file pointer. But still on line 39, we are calling it the right way. On line 40, we are calling it the wrong way, but it's still, but A.out will work it with a, it will give segmentation fault. Are you all with me here? So what could have been caught at the compile time, we are compiling, we are getting it, we are catching it at the, what do I say, at the runtime. Are you all good here? So now but let's say if we include the prototypes, I include the prototype here. Now it says too few arguments to the function and it cannot compile. Are you all with me here? Do you understand what we are doing? So now the error is caught. So that's the reason it's important to include function prototype so that we don't end up making mistakes. So now we delete this and we have this, and it compiles well. Names.txt. It works. Great. This is the main.c code. And so maybe we can kind of have this in helper.h file, all these things, helper.h, and then we say hash include header.h. Great. All good. Yeah, I will add this code to the repo. So one more thing I want to say, there is this idea of scoping. So the namespace, the read names function and all these functions, by default, they are visible to functions which are written in some other files. But sometimes, like for example, you have written a swap function and your friend is also using a swap function, then you will collide, right? Isn't it the case? Like you are using in helper.c, you are using swap, but your friend is also using a swap function, and then there will be a problem, right? So when you try to compile, you will see, like for example, so the programmer, for some reason, in main.c, he wanted to have his own swap file, whatever it is. Okay, so let's say he has a swap which looks like, yeah, let's say he has a swap like this, because for some reason, he wants to use his own swap. So if we compile this, what happens? Is it all right if I take a couple of more minutes to finish this discussion? You will see there's an error because there are two swaps defined. So in helper.c, there is a swap, and in main.c, there is a swap, and there is a problem. How can we solve this problem? So rename the functions for one. Good option, Pratyaksh. So if a team of 5-6 people are working, so and all these things, they cause real trouble for you, file path is not going to help. So you have to you can use a keyword called as static. So when you use the keyword static, then what happens is this swap function is visible only within this function. It is not visible to outside of this function. So now it works. So when we we have heard about, we read about, we learned the scoping rules, lifetime and scoping. So that's what static. That's why you should pay attention. You are busy chatting. Pay attention here. So so static. What static does is it reduces the scope of this variable, this function swap, to only this file. To only this file. So what happens is when swap is used, so that swap is kind of only restricted to this file. So it's not visible in the global namespace. So when you use a swap in this file, the swap will be referred, the swap that you will be referring to is the swap that is there in this file. Yeah, so no other file compiled at the same time can call this swap function. That's true. That's true. And static will mask the other swap and won't let this swap be used in other file. That's true. So the static keyword, using the static keyword, you can kind of restrict the scope of a variable to this function. No, what if a function wants to call swap in another file? It's not possible. No, no, no. It will, in the main, when we call the swap, it will use the swap which is defined in that function. If the other swap is not static, it should be visible in the main, but it will be masked by the swap that is present here. Or let me use a different example. So let me comment out this code. Let's go to helper dot. So let me do one thing. So what if I keep static here? What will happen? Static here. I'll just take 2 more minutes and I think I should stop. So now if you keep static and if I compile, what will happen? See, there is an error. Read names, you can see here. That is because it is there, no implicit declaration. This says no implicit declaration or whatever, but it's not finding static if you try to compile here. If you made static at both the places, it's not going to work because it's a kind of yeah, static in header doesn't make any sense though. Yeah. But in any case, I want you to take one step back. Can someone summarize in single sentence, what's the moral of the story? Name your functions better. Prototype first, code later. Don't use same named functions. It's not in your control. Yeah, so static on a function reduces the scope of the function to within a file. That is the all right. So this is the story. We have to good. So in order to keep the global namespace clean, always use static on those functions which you know for sure will not be used by other functions. Was this linked list? Krishna Pranit. It's okay, it's okay. Okay, I think so. There is one more thing. I think we are running out of time. So, with variables, the story is a bit different. I want you to explore how variables work, how the scoping for variables work across files. So, in the next class, so when should we have the makeup class? Tomorrow. Can we have the makeup class? Yeah, yeah. Structures. There are structures, unions, linked lists, or Tuesdays, or today is fine. Huh?